Hello guys, welcome back to my channel, Based on African Motives. Still working on engineering, working on mathematics N2. So in this platform, we are not going to waste much time. We are going to focus on the question paper, which was actually written in November 2022, which is an X paper for NATED engineering. So we shall proceed. So take note, there we were given requirements, 2 sheets of graph paper. We are told the graph paper, then the scientific calculators may be used, which means you can use calculators in this paper. All right, then what is important are the instructions and the information. Please make sure that when you are answering questions, please make sure that you read. In this case, I think all these instructions, they are straightforward. So we shall quickly rush through the first question of the paper, which is question number 1, where we are being asked to simplify the following without the use of a calculator. So this is the most important part, without the use of a calculator. So when they're saying without, they are just referring, do not simplify exact from a calculator. Yes, there are some other steps that you can, like you want to add or to subtract, you can use your calculator there, but not to simplify direct the answer, because take note of the marks that you'll be given. 3 marks, which means you have to show working. Okay, the first question, which is 1.11, we were given the fourth root of this expression. So what we are supposed to do here, there were so many options that we can take. We know that if we are given the square root, let me write in this format so that we can understand. Let's say it's the 8th root, or let's say the bth root, so that it can make sense. Let's put b here, x to the exponent of a. Whenever we are given this format here, we know that this was actually taken from x to the exponent of a over b. So that was the format that we are supposed to take. The 4 that we see here is the same as the b. So we can take this, then the 6 here is the same as the a. So this is our a, this is our b. So which means we can write this as a squared, b squared, everything here to the exponent of 6 over 4. Just like here, we have got a over b. So a is the exponent, b is the number inside the root. So it's going to be 6 over 4. So this was going to be 6 over 4. Okay, so everything here over. Down here, we can actually simplify a and a is multiplying each other. From this part, we've got a to the exponent of 5, a to the exponent of -2. We know that when we are multiplying, we add the exponent. So it's going to be a to the exponent of 5 plus -2. We move on to b to the exponent of 7, and b to the exponent of -4. So it's going to be b to the exponent of 7 plus -4. So this is simplification. All right, so let's simplify. So now on this stage, guys, you can use a calculator just like to multiply. Remember, guys, from your laws of exponents, let me write it here so that it can be clear. We actually know that x to the exponent of a to the exponent of b is going to give us x to the exponent of ab. So here we're supposed to multiply 2 times 6 over 4, okay, which can actually give us 3. All right, or you can just use your calculator to multiply that. So we're going to have a to the exponent of 3. The same thing here for b to the exponent of 2 times this, which is going to be the same. So it's going to be b to the exponent of 3. Everything over, we've got plus or minus. So 5 plus or minus 3 is same 2. Same as 5 minus 2, which is 3. So 5 minus 2, that is 3. Plus and minus, that's a minus. So it's 7 minus 4, which is also 3. So it was going to be b to the exponent of 3. So as you can see, these two are actually the same. So we can actually cancel this and this can cancel, this and this can cancel. So that means we are going to obtain a 1. Yes, if you wanted to apply the laws, we are dividing, so you can subtract, you can write it as a to the exponent of 3 minus 3, b to the exponent of 3 minus 3, which is a to the exponent of 0, b to the exponent of 0. We know that a to the any number to the exponent of 0, it's a 1. So it's 1 times 1, which is going to give us a 1. So still we're going to obtain the same answer. There are so many ways that we can use, guys, to simplify this. Okay, so I'm just going to erase this part so that we can have the other part. Okay, let's see this part here, which is 1.12. We're given logarithms, and for logarithms, what I want you guys to know are the laws, okay? Especially here we can see that we have got the log of 27 base 3. Let's simplify this first. log 27 base 3, we actually know that if we have got something like this, log of a in base of 8 is going to give us 1, and also log a to the exponent of m in any base is going to be m log a. So these are the most important laws that we are supposed to apply here. Okay, so let's see this part. If I'm to simplify here 3 and 27, 27 is same as 3 to the exponent of 3. So I can rewrite this as, okay, I'm just going to write it here. Okay, so I'm going to rewrite this part 27 as in base of 3 because we want these numbers to be the same, a and a. Okay, so it is going to be log 3 to the exponent of 3 in base of 3. But take note, there is an exponent of 2 which is already there, plus the 1 over 64 here. We know that from our laws, x to the exponent of minus 1 is 1 over x. So that means 1 over 64 is same as 64 to the exponent of minus 1. So let me write it here, 64 to the exponent of minus 1. But we want to write it in base of 8. We know that 64 is same as 8 to the exponent of 2, but there is a negative which is already there, so it's going to be minus 2. All right, so we can rewrite this as logarithm of 8 to the exponent of minus 2 in base of what? In base of 8. Then everything that we have here, we raise to the exponent of 3, then the whole bracket to the exponent of minus 1, this negative 1 that we have here. All right, so from this stage, guys, that means we can simplify now. Let's apply the laws. Remember this law that I talked about. If there is an exponent, we have to drop that exponent to multiply the log. That is the 3 here and the minus 2. So which means from this stage, we can have something like this. Drop this exponent here. We are going to have 3 log. So it's going to be 3 log 3 in base of 3, everything to the exponent of 2. Plus, we do the same here, drop this exponent here. So it's going to be negative 2. So it's going to be negative 2 log of 8 in base of 8, everything to the exponent of 3, then everything to the exponent of negative 1. Okay. Then from this stage, we are now back to this law, which I referred to. The logarithm of a number, same number, here, a and a means this is the same number that we have. So we're going to obtain a 1. So which means log 3 base 3, that's a 1. Log 8 base 8, that's a 1. So what are we going to have at the end? I want you to see this part. We are going to remain with something like this. This is 3 times 1 because this is now a 1. So 3 times 1, that is 3 to the exponent of 2, plus negative 2 times 1, which is negative 2 to the exponent of 3, this 3 that we see here, everything to the exponent of negative 1. Okay, so let's see what we're going to have at the end. If we are to simplify, we are going to obtain, let's see here, 3 to the exponent of 2, that's 3 times 3, which is 9, plus negative 2 to the exponent of 3. That means negative 2 times negative 2 times 3 times, which is going to give you negative 8, but everything to the exponent of negative 1. Okay, so simplify the inner bracket first. We put plus and minus, which is a minus. So 9 minus 8, that is a 1. So which means we are going to have 1 to the exponent of negative 1, which is just a 1. Guys, 1 to the exponent of any number, it remains as a 1. So that means that is what we're supposed to do. So if we are to cross-check, if we are to apply these stages properly, guys, I think we can obtain all the full marks, which is 3 marks. Okay, so let's see the other part of the question, which is 1.2. We asked it to solve the logarithm that we are given there. All right, we have got the log x, log 9 in base of x. Okay, so just like what we did in the previous part, that is what you're going to do here. But knowing that logarithm of 1, guys, we must know this. The logarithm of 1 in any base is going to give us a 0. So this one has a 0 there. So I'm going to rewrite this as log 9 in base of x plus a 0 here. We got a 0 here. Okay, what about minus log 1 over 16 in base 4? Just like what we did on 1 over 64, this is going to be 16 to the exponent of negative 1. But if we are to write in base of 4, remember 16 is 4 to the power of 2. Because of the negative 1 that we have, so it's going to be negative 2. So that means we are going to have minus the logarithm of, In place of this 1 over 16, we are going to substitute now with 4 to the exponent of -2 in base of what? In base of 4. This is going to give us a 3. That is what we have there. Okay, so that's the 0 part that we have here doesn't mean anything, so just ignore it. Okay, so let's move on to logarithm of 9 in base of x. From that law that we mentioned previously, we said we're going to drop this exponent, so it's negative times -2, which is a positive 2 now. So it's going to be positive 2 log 4 in base of 4, which is equal to 3. Remember, guys, what I said, the number and the number here are the same. So we are going to obtain a 1. So that means we've got the logarithm of 9 in base of x, 2 times 1, which is 2. So it's going to be plus 2, which is equal to 3. Then from there, we can actually simplify log 9 in base of x is equal to transpose 2 to this side is going to be -2. That means 3 minus 2, which is 1. So what are we going to have at the end for us to have x? Remember what we said, guys. In this case, there were so many ways that we can actually use to simplify this part. There were so many ways that we could have used. Which are the ways? Okay, I mentioned previously that the logarithm of a number in base of that same number is 1. So definitely for us to have 1, it means this x here is supposed to be equal to 9, so that the number and the base are the same. So therefore our x was going to be 9. Or you can actually convert this to index form. If this was not quite clear, we can convert to index form. The logarithm of 9 in base of x is equal to 1. Remember, in index form, this 9 is equal to x to the exponent of 1, of which any number to the exponent of 1 remains as it is. So therefore, x was going to give us a 9. So there were so many ways that we could have used here. Now, if x is a 9, that means we're going to have 1 plus 2 here, which is 3, and that makes sense. Okay, so that was the actual part that we could have done from this one. Let's see the other part, which is on, let's see, sorry, that is 1.3. So on 1.3, we are asked to solve for x. Solve for x. Okay, let me have the equation here. That's 1.3. From this part here, what is important is for us to write these numbers in the same base. That is from 64 to 16 to 256. Each and every number has to be written in the same base. And the base that we can actually use is 4. Let's try and see. 64, we know that is 4 to the exponent of 4. 4 to the exponent of 3, not 4, guys. This is 4 to the exponent of 3, 64. So we've got 4 to the exponent of 3, like this, okay? 4 to the exponent of 3. But remember, there is already an exponent which was there, which is 2x plus 1. So it's going to be into 2x plus 1. Everything over. We've got 16 here, of which 16 in base of 4, that's 4 to the exponent of 2 into x minus 2, which is equal to 256. That one is the 4 to the exponent of 4. Okay, so that is 4 to the exponent of 4. All right, so just like a normal equation, here we are supposed to simplify first the left-hand side to have a simple expression that we can work from. Remember, if there's an exponent, it has to multiply everything inside here. So we are going to have 4 to the exponent of 3 times 2, which is 6x, 3 times 1, which is 3. Everything over 4, we've got the same scenario here, 2 times x, which is 2x, 2 times -2, which is -4, and this is going to give us 4 to the exponent of 4. All right, then we know from our laws that if we are dividing same bases, we are going to subtract. Divide by x to the exponent of b, that's x to the exponent of a minus b. So here, that is what you're supposed to do. You're supposed to subtract because we are dividing. So I'm just going to take this on this other leaf here. That means we are going to have 4 to the exponent of 6x plus 3. Then we subtract this exponent that we see here, which is 2x minus 4. So we are going to subtract 2x minus 4 and equate this to 4 to the exponent of 4, which is already there. Okay, so let's simplify first. The left-hand side, we're going to have 6x plus 3. negative times x times 2, that's negative 2x, negative times negative here, that's a positive 4, which is equal to 4 to the exponent of 4. Collect like terms, that's 6x minus 2x, which is 4. So it's 4 to the exponent of 4x. 3 plus 4. We are adding 3 and 4, which is the like terms, that is 7. And we are going to have 4 to the exponent of 4. Now we have this condition from our exponents, guys. If we have got x to the exponent of a, which is equal to x to the exponent of b, the bases, if they are the same, it simply means these exponents are also the same. So that was the condition that we are supposed to apply now at this stage to say the exponents, which is 4x plus 7 is equal to 4 because the bases are the same. So we are going to equate 4x plus 7 to 4. That's it. Now we have got a normal equation, which is a linear equation that we can actually solve. So 4x is equal to transpose 7 to the other side of the equation. That would be minus 7. So 4 minus 7, that is negative 3, divide by 4, divide by 4, both sides. So therefore, our x was going to be negative 3 over 4. All right, so that was actually the condition that we could have used to calculate the value of x. So many ways that we can use, but I think this one was a little bit clear. I don't know which other part that you can, but there are so many ways. Okay, let's see the other part, which is 1.4. We were given a formula to work on, and from this formula, make h to be the subject. I'm just going to put it this side here. Okay, so we have got the equation, which is s, that is 1.41. Okay, so we've got s, which is equal to, then definitely, guys, we have to expand brackets here. So we've got pi r times 4r here, which is going to be 4 pi. R and r here is going to give us r squared. Okay, we've got pi r times 2h. So this is going to give us 2 pi r h. Okay, so 2 pi r and h. Okay, so to make h to be the subject, we can actually transpose this other side because it has this other part here term, because there is no h on this part. So we can actually transpose to the other side, which is going to be negative 4 pi r squared, which is equal to 2 pi r h. So to find h, since we are multiplying, we are going to divide by what is multiplying, which is 2 pi r on both sides, 2 pi r. So this can cancel. So therefore, your h was going to be s minus 4 pi r squared over 2 pi r. So that is what we're supposed to have for the value of h, or the expression to show h as the subject. Okay, 1.42, now we are being asked to calculate the value of h given that r is 2,45, s correct to 3 decimal places. So this was just a substitute. Already h is the subject here, so you can just substitute. That is 1.42. So you can just substitute here 1.42. H is equal to s, and the s here we are given our s as 149,7. 149,7 minus 4 pi r squared, which is the radius, which is 2.45 here, 2.45. So it's 2.45, but take note, there is a squared. Everything over 2 pi r, which is 2 pi times the radius again, which is 2.45. Okay, so the rest is your calculator now. It's all about your calculator. Make sure that we simplify everything properly. Put in the fraction 149.7 minus 4 pi times 2.45 squared. Okay, everything over 2 pi. That's a pi here times 2.45. Okay, so we are going to have 4.8246, which is 4.825. 4.23 decimal place. This 6 is going to change this one into 5. So it's 4.825. 4.825. Okay, so that was the value of h. That's a substitution, guys. Just a substitution here. 3 decimal places here. Take note the instruction to 3 decimal places. That's why we have to round off here to 3 decimal places. Okay, 1.5. I'm going to use this part here, so that let me remove this. Okay, on 1.5, you're now given the equation. Solve for all values of x in the following equation, so that's a quadratic equation. Okay, so let's see the equation that we're given. We can even write it here. All right, so let me just change this one. I think it can be clear. 20x squared, so this is 1.5. We've got 20x squared plus 9x. So I can transpose the 18 to this side. So it's going to be a negative 18 is equal to 0. So that's a quadratic equation. You can try to use factorization, but if you see that there's a lot, then just use the quadratic formula, because we know that our quadratic formula states that x is equivalent to negative b plus or minus the square root of b squared minus 4ac, everything over 2a. Okay, so now let's work out the value of x, because we've got our a here, our b, and our c. So that's our a, our b, and our c. So x is going to be negative b, which is our b here, which is 9. So it's negative 9 plus or minus the square root of b squared, which is 9 squared, minus 4 times a, which is 20, times c, which is negative 18. Then everything over 2 times a, which is 2 times 20. Okay, so just try, guys, to simplify stage by stage. We've got negative 9 plus or minus the square root of. So I'm going to simplify this part here under the square root, only this part that we see here under the square root. Let's have an answer for that. Okay, that's don't use anything. Just put if the values negative 9 squared minus 4 times 20 times negative 18. That's something like 1521. Okay, so that's 1521. 1521. Okay, everything over 2 times 20, that's a 40 here. 2 times 20, that's 40. So we can actually separate from there, or you can just use your calculator direct from this stage, or you can separate the answers. Since we've got a plus or minus, we can have x, which is equal to negative 9 plus the square root of 1521 over 40, or the other x, which is going to be negative 9 minus the square root of 1521 over 40 here. So that means we can just simplify now direct from our calculators. Fraction, negative 9 plus the square root of 1521, everything divided by a 40 here. We are going to obtain 3 over 4 or 0.75. So that was 3 over 4 or 0.75. So 0.75. Or the other x is going to be, we just put a negative this time here. So that is the only condition. I just have to change here and put a negative. That's like this, which is negative 6 over 5, or as a decimal, negative 1,2. So we are going to obtain negative 1,2. All right, so that's negative 1,2. So these were the values of x that we could have obtained from that equation that we are given. So like I said, guys, it depends with the formula or the method that you're going to use. You could have used the factorization method, still you're going to win, or we just focus with the quadratic formula. Okay, 2.11 from question 2, fully factorize the following expressions. Okay, so let's start with the first one. We are given on 2.11, which is 6b squared, whatever that we have. But if we have to cross-check here, we can see that between 6, 27, and 15, there is a highest common factor there, which was 3. So we can actually factor out 3 first. Before anything, we can factor out 3. Okay, that's 6 divided by 3. We are going to have 2b squared minus 27 by 3, which is going to be negative 9b. Minus 15, which is negative 5. So this is what we're going to have. So from there, we can apply the longer way of factorization. Remember, guys, here, the coefficient of b squared, there is a number here. So it's not easier for us to use the shorter way. We are going to apply the longer way, where I told you that you have to multiply the first term to the last term. So 2 times negative 5, that's negative 10b squared. And what are the factors of negative 10b squared? But from these factors, if we add, we must obtain the middle term, which is minus 9b. So we've got minus 10b and b. If we multiply this, we get negative 10b squared. If we add here, we get minus 9b. So that these are the factors that we're supposed to use. So we've got 3 into 2b squared minus 10b, or you can just use plus b minus. I don't know the way that you're supposed to use for you. So we've got minus 10b plus b minus 5. So as we can see here, if we add, we get 9 minus 9. Okay, so from there, remember that we now have 4 terms. That's 1, 2, 3, 4. So you can group them into 2. For the first 2 terms, what was common was 2b. So we've got 2b into 2b squared divided by 2b, that's b, minus 10b divided by 2b, which is negative 5. Then already we've got b minus 5 here, so we can factor out plus 1 so that we remain with b minus 5 as it is. Okay, so the 3 is still there. The 3, you have to write it until the final answer. So still we have our 3. So it's 3 into, remember, if the brackets are the same, we just have to take one of the brackets, just factor out b minus 5. And what do we remain with? We remain with 2b plus 1 in another bracket. So it's going to be 2b plus 1 in another bracket. So that was it, guys. So take note, this is a b here. So that was it for you to have 3 marks for that factorization. Okay. If we are to cross-check on 2.12, 2.12, there we are now given something like this. Let me just try to erase this part. Okay, so I'm just going to erase this part so that we can even write it here. Here we have something, a difference of 2 squares. Remember, from difference of 2 squares, I told you guys, we have to write your numbers in terms of powers of 2 or the exponents of 2. Okay, so this was same as from 1. 1 is same as 1 squared minus 16. This is 4 squared. X to the exponent of 20 here is same as x to the exponent of 10 to the exponent of 2. So as we can see, we've managed to write in terms of powers of 2, in powers of 2, in powers of 2. So that means we can apply the difference of 2 squares. Remember, one bracket adds, another one subtracts. So we're going to have these numbers, which is 1 and 4x to the exponent of 10, the one which is being raised to the power of 2. So that is it, guys. Let's see, but that is what we're supposed to have here. So it's going to be 1 minus 4x to the power of 10, okay? Then another bracket can add 1 plus 4x to the power of 10, okay? As it is not enough, because we still have another difference of 2 squares here. Okay, we still have another difference of 2 squares because these numbers here, 1 can also be written back. Remember, we said 1 is same as 1 squared. Okay, 4 is same as 2 squared. Then we've got x to the exponent of 10. X to the exponent of 10 is same as x to the exponent of 5 to the exponent of 2. So that means we've got another difference of 2 squares where we are going to have 1 and 2x to the exponent of 5. Okay, so that means we are going to have 1 plus 2x to the exponent of 5. Okay, we can start with the minus, we can start with the plus. I don't know which one was best for you. 1 minus 2x to the exponent of 5. Then this bracket remains as it was because there is no sum of 2 squares. So there's nothing that we can do from this bracket. Okay, we cross-check again. Do we still have any difference of 2 squares? As we can see, we no longer have a difference of 2 squares. Yes, 1 is a perfect square, 2 cannot be a square, 5 cannot, so which means our answer was going to be at this stage. Okay, so that was it on 2.12. Let's cross-check the other part, which is on 2.13. Okay, so I'm just going to erase this for a minute. Okay, 2.13, we have got a certain expression which has got 4 terms. If we are to count these terms, that's 1, 2, 3, 4. Remember, I told you guys, once you have got 4 terms, it's all about grouping them into 2 so that you are able to factorize. But if we are to cross-check here, the first 2, there's nothing that is common. So what are we going to do now? We are going to rearrange the expression. So here I'm going to have 5x and the last part, which is going to be 5x plus 3ax. Okay, then from that order, I can even start with this one. Since here there is 5, 3, here there is 5, there is 3. So I'm going to start with 5. So it's going to be negative 5a followed by negative 3a squared. No matter the way, but that was the best arrangement. Since here we've got 5, 3, 5, 3. Okay. From this stage, we can now factor out what is common from the first 2 terms. which is fine, which is x. It's only x which is common here, x and x. So you can factor out x, we will remain with 5 plus 3a. Okay. For us to have 5 plus 3a here, we are supposed to factor out a negative a. A negative, it becomes a positive, so it's going to be 5 plus 3a. Okay, remember guys, the brackets, once they are the same, factor out that common bracket, then you remain with x minus a in another bracket. So we've got x minus a in another bracket. So that was it. 3 marks for that, guys, these people. Okay, anyways, let's check 2.2. We are now given certain expressions that we are supposed to work from, and from these expressions that we have, the first part was to determine the lowest common multiple, which is the LCM. Guys, I told you about LCM. LCM, already these are factorized expressions. They already factorized for us. So it was just a matter of taking the answers. Okay, so remember LCM, we have to take everything, but on a condition like this, we have got a plus 1, a plus 1. We have to take that as it is. So our LCM was going to be a plus 1 into a plus 1. Then we are done with a plus 1. We've got a plus 2. Got a plus 2. It's appearing once. We've got a minus 7. It's appearing once again. So this was going to be your LCM. Then the HCF for this one was going to be what? HCF, I told you, it's a highest common factor. It has to be common throughout. A plus 1, a plus 1, a plus 1. So that is the highest common factor. It must be common throughout. So it was a plus 1 as the highest common factor. So you can see, guys, it was just like that. We've got 5 marks for everything. Okay, so that was it on question 2.2. In fact, to question 2. Let's see that a part of question 2. Question 2.31, which is now for us to simplify. Okay, so I asked you to simplify the following expressions. So as we know, guys, if we are to simplify, the first thing that we're supposed to do is to try by all means to do the factorization possible. Please do factorize. But here there was a tricky part that was there on this question. The tricky part is, I want you to see something, the arrangement of the minus a, this arrangement here, the minus a squared, the minus a, the 6 there. We can actually factor out a negative so that this can be a positive. So we're supposed to write this as 2.31. Okay, so we can write this as 6 over a plus 3. The moment I factor out a negative, it is going to be it's going to affect this side. So this was a plus, so it's going to change into a negative. So we've got negative a minus 2 over. Now I want you to see something. Remember, we factored out a negative. We had to factorize to remove the negative first. So if we remove a negative here, it is going to be positive a squared. We do the same here. We factor out a negative. It is going to be positive a. Here it was a positive. So if I factor out a negative from a positive, it's positive divided by negative. So it's going to be a negative 6. So that was it, which means this sign is going to change. It's now a minus because you've got minus and a plus. Okay. Anyways, before we proceed, the first thing now, the other thing now is to factorize. So from this part, let us now factorize 6 over a plus 3. There's nothing that we can do here. We've got a minus 2 over. Here we've got an advantage. The coefficient of a squared, it's a 1. So remember, I told you guys to just have 2 brackets that we're going to have with a and a. What are the factors of minus 6? This is your consideration. The factors of minus 6, but if you add, you're supposed to get the middle number here, which is 1. So the factors, we've got 3 and minus 2. 3 times minus 2, that's negative 6. 3 plus minus 2, that's a 1. So which means these are the factors, a plus 3, a minus 2. But what is happening here? We've got a minus 2. I want you to see something. The a minus 2 here and the a minus 2 are the same. So these can actually cancel out because it's from the same fraction, which means now we are going to remain with a 1 on the top there. All right, so this was it. We are going to have 6 over a plus 3 minus 1 over a plus 3. Knowing that if the denominators are the same like this, we're just going to take that denominator as it is, then we subtract direct the numerator 6 minus 1 which is going to give us a 5. So the answer was going to remain as 5 over a plus 3. So that was it for 2.31. Okay, let's see the other part now, which is 2.32. I'm just going to remove also this part. All right. So on this part, again, the first thing was to factorize before we talk of anything here. So let us factorize 2.32. All right. The advantage that we had exactly here, the coefficient of a squared is 1. So you just have to focus on 4. What are the factors of 4? But if we add, we must get minus 4. So we've got minus 2 and minus 2. Minus 2 times minus 2, that's a positive 4. Minus 2 plus minus 2, that's a minus 4. So these are the factors that we're supposed to use. So we've got a minus 2, a minus 2. Everything over here, we've got a squared minus 1. Remember, 1 can be written as 1 squared. So that's a difference of 2 squares. We've got a and 1. So we are going to have a plus 1, a minus 1. Okay, divided by the same here, a is common, so you can factor out a. If we factor out a, you're going to have a squared divided by a, which is a, minus 2a divided by a, which is a minus 2, everything over. A, again, is common here, so you can factor out a, which is going to be a squared divided by a, that's a minus a divided by a, you're going to have minus 1. Okay, so that was the first part. Then the introduction of the multiplication sign. Since we are dividing, I told you guys, you have to introduce the multiplication sign. But the moment you do that, don't forget to interchange the fraction, which is the second fraction. Okay, so we've got a plus 1, a minus 1, multiply by, then we interchange this. So we are going to have a into a minus 1 over a into a minus 2. Now we can cancel as long it is on the numerator and the other part is in the denominator. We can cancel it like a minus 2, a minus 2, a and a. We've got a minus 1, a minus 1. So as we can see, that is what we can cancel for now. So what is remaining on top? We are just remaining with a minus 2. What is remaining in the denominator? We are remaining with a plus 1. So that was going to be a plus 1, just like that. So this was the final answer that we are supposed to have for you to have 3 marks. And guys, just take a look, closer look, 21 marks on question 2. This was a lot of marks, but I think we now know what was supposed to be done. Question 3. Solve for x and y the following equations algebraically, which means we can use any method for algebraic. That is substitution method, any method that you can think of, as long as algebraic, not graphical method, but algebraic. So which means here we're going to choose any. For me, it was actually best for you to work with substitution. Why? Because already x is the subject on equation 2. We can name this equation 1, equation 2. So already x is the subject. As we can see, x is equal to 2y minus 2. So you can substitute it into the first equation. Okay, so that was our 3.1. So 3y plus 6 is equal to 6 times x, which is 2y minus 2. That's 2y minus 2 in a bracket. So you have to put in a bracket so that 6 can multiply everything. So 3y plus 6 is equal to 6 times 2. That's 12y. 6 times minus 2, that's minus 12. So I can collect like terms. That means we've got 6 here and minus 12. If I transpose the minus 12 to this side, it's going to be a plus. So it was going to be 6 plus 12, which is equal to 12y. If I transpose the 3 to this side, it's going to be a negative. Since it is a positive, then it's going to be a negative 3y. Okay, 6 plus 12, that's 18, which is equal to 9y divided by 9, divided by 9. So y is equal to 2. Since y is equal to 2, and already on this equation, we are given that x is equal to 2y minus 2. So I can substitute the y that I got here, which is 2. So it's going to be 2 times 2 minus 2. So 2 times 2, that's 4 minus 2. So x was going to be 2. So x is 2, y is 2. That was it. So as we can see, guys, that was the consideration from this part that we had. So it's just a matter of simplification. Know what you're doing, guys. Know what you are doing in exam. Okay, so anyways, that's it. Let's see the other part. Let's see the other part, which is 3.2. The diameter of a wheel. We are given the diameter here of a wheel, which was 80 millimeters. And okay, let me just write it down. This is 3.2. Okay, 3.2. Let me write it here. We are given the diameter, which is 80 millimeters, and the wheel rotates, that is the rotational speed, but we know that our n is supposed to be in revs per second. So this n to be in revs per second, we divide per minute, we divide by 60. So it was going to be 0.25 over 60, which is now revs per second, okay? So this is the information that we have for now. The first question was for us to calculate the angular velocity of the wheel. Okay, so on this one, if you've forgotten, please use your formula sheet. On the formula sheet, we are given, right, let me do this. Let me show you this part. I think it's down here. All right, here we have got two things that we have got that we are supposed to apply on the angular velocity. We have got the angular velocity, which is omega, which is 2 pi n. And we are told that this n is the rotational frequency in revs per second, that is revolution per second. So take note, your n here is supposed to be in revs per second. Okay, so that means we could have applied that same situation here. Sorry for that, guys. I added another page, which I'm not supposed to add. Sorry for that. Okay, I'm supposed to get back to that part that we had before. So we've got 2 pi n there. Okay, so here our angular velocity, which is omega on 3.21. So this was 3.21. Omega is equal to 2 pi n. So we've got 2 pi times n in revs per second, which was 0.25 over 60. So that's it. We can just use your calculator direct to simplify this one. Okay, so let's just put it here. Okay, we've got 2 pi, 2 pi. Did I put the 2? I didn't. 2 pi. Okay, so that's 2 pi times 0.25 over 60, like this. Okay, so we're going to have 1 over 20 pi or 0.026. Yeah, 0.026. That's 0.026. This is the angular velocity, which is measured in rad per second. So this one is rad per second, not revs, but rad per second. Okay, so that was it. Then if you have to cross-check on the other part, it was the peripheral velocity. Okay, so let's see this one, which is the, okay, peripheral velocity of the wheel. So this one is for the linear, which is the V. And you saw that that one was 3, let me write it here, 3.22. So we've got 3.22, which is V, and V was equivalent to pi dn, whereby this d is supposed to be the diameter in meters. So you've got millimeters. Milli means times 10 to the power of -3. So that means our V was going to be pi times the diameter, which is 80 times 10 to the power -3 times n, which is the n that we had here, which is the 0.25 over 60. So that was it. We can actually use our calculator to simplify this. We're going to obtain something like 1,047 times 10 to the power -3, something like that in meters per second from the calculator. So just cross-check on the calculator. That's it, 3.22. All right. The other part is we are given that calculate the area of a sector, that is 3.3. Okay, let me just do this way. All right, so we have got 3.3 here. Calculate the area of a sector if the circumference of a circle is 25 centimeters and the angle of the sector is 55 degrees. Okay, we've got something like this, guys. This is the question. We have got the circumference of a circle, which means we've got a circle like this, which has got a circumference of 25 centimeters. Okay, and we are given that the angle of the sector is 55 degrees. So the sector from where it was taken, this is our sector. Here it has got an angle of 55 degrees. And we actually know that we are supposed to convert these angles to radians. So the question was for us to calculate the area, take note, calculate the area of a sector. Okay, but we are given the circumference of a circle. Why are we given the circumference of a circle? We can actually obtain the radius from this, because from this sector, we do not have the radius. So we can calculate the radius of the circle. Then we use that one to calculate now the area of the sector. Okay, so first things first, let's calculate the radius. We know that the circumference of a circle is equal to 2 pi r, and we are given that it is 25. So 25 is equal to 2 pi times the radius. Since we want to calculate the radius, we just have to divide by 2 pi both sides. So our radius was going to be 25 over 2 pi centimeters, or you can find the decimal, something like that. Okay. We move on to the angle of the sector, the theta. We know that this one is supposed to be measured in radians. So we're supposed to convert to radians, knowing that in a 180 degrees, we have got pi radians. So what about 55 degrees? How many radians do we have from there? That was the question that you're supposed to ask yourselves. As you can see, this is less. We can use simple proportion, whatever that you can use, but this is less. So it's 55 over 180 times pi. So which means our theta in radians was going to be 55 over 180 times pi, of which we can simplify. 55 over 180, that's something like 11 over 36 pi. Okay, so we've got theta in radians, and we have got the radius. Now we want to calculate the area. Take note, the question was for you to calculate the area of a sector. And we know that from our formula, if theta is in radians, therefore the area of a sector can be given as, take note that area is equivalent to half r squared theta. So we can simplify. Area is equivalent to half r squared, which is the radius that we got here, which is 25. So it's going to be half times 25 over 2 pi, but everything has to be squared, times theta, which is 11 pi over 36. All right, so that's it. We can actually obtain our area from this formula. So let's see if we can have it. That's half 1 over 2 times 25 over 2 pi. So this is 25 over 2 pi to the exponent of 2 times 11 pi over 36. So it's 11 pi over 36, like that. We can use your calculator, which is 7.5985. If we round off to 3 decimal places, it's going to be 599. Okay, so it's 7.599. This is area, which is measured in square units, and that's square centimeters, because the other part here we are given circumference of a circle, 25 centimeters. So your units now is going to be square centimeters. So that was it for the area of a sector. All you needed was to calculate first the radius, then the angle in radians. Then from there, we can use the formula for area, which is half r squared theta from this information that we have. Okay, let's see this part here on 3.4. 3.4, we are given that there's a sheet of paper in the shape of a circular sector, which is this one. So this is the sector that we are given of radius 1,3, which means this radius was 1,3 centimeters, 1,3 centimeters, and an area of 0,6. We are also given the area, which is 0,6 square centimeters. If the sector is bent into a shape of a cone, calculate the perpendicular height of the cone. Okay, we know that this is a cone actually that we have. We know we are going to have the radius, and this is going to be the perpendicular height that we have, which is this x that is given. So actually this was an error, because the height, the x that we are given here, because we are given the hint that from this sketch, the height is the x, and also here we've got x. So the height was just 1,3 because it is the x that we see here. So I think there is an error that actually there's an error in asking of the person. Maybe they wanted you to calculate the slant height or something, not the because the perpendicular height is this one, which is the x that you are told that your x here is the same as this x that is there. So you are calculating nothing there. Okay, so that's a mistake. We don't know what the question was supposed to be. We just wait for them to give us full marks, 3 marks for that. Okay, 3.5, the volume of a closed cylinder is, and also the height is 30 centimeters. Calculate the surface area of the cylinder. All right, we are talking about a cylinder here. Let's list what we have, okay? From this cylinder, okay, let's take the information properly. Okay, I can even write it down here, it's fine. Okay, so like I said, we have got the volume. So this is 3.5, the volume of a cylinder, which is 506.6 cubic centimeters. We also have the height, which is 30 centimeters. So the question was for you to calculate the surface area for the cylinder. Okay. So this is what you're going to have first. We actually know that the volume of a cylinder is pi r squared h. Okay, so let's see what we can obtain from the volume. Sorry for that. Let me remove this. Okay, sorry. So we are going to have our volume. So take note of the formulas, guys. Your volume is going to be pi r squared h. Okay. Then actually, okay, let's see here. I want you to show you something. Right. Let's see. Okay, here we've got our cylinder, which means we can actually work the volume pi r squared, then the surface area 2 pi r squared plus 2 pi r h. So everything is there. All right, so which means we can have our information. We say the surface area is 2 pi r squared plus 2 pi r h. Okay, so everything is there, but on the surface area, because the question is asking you to calculate the surface area, we do not have the radius here. We do not have the radius. So that means from the volume, we were supposed to calculate the radius from the volume. Since we have the volume here, we can substitute the volume. 506.6 is equal to pi r squared. We do not have the radius, but we've got the height of 30 times r squared. So we are going to divide by 30 pi, both sides, divide by 30 pi, both sides. So this can actually cancel. So r squared is equal to, we are going to remain with a fraction here, which is 506.6 over 30 pi. So this is what you're going to have. So definitely to find the radius, introduce the square root both sides. So that means your radius was going to be the square root of this answer that we see. So let's see here the square root of the fraction of 506.6, everything over 30 pi. So this is 30 pi, okay, which is going to be 2,3184, something like that, which is 2,318. So we're going to have 2,318 centimeters. So now we have got the radius. We can calculate the surface area, the formula. We have our formula, so that means it's just a matter of substitution into the formula that we have here. We said our surface area is equal to 2 pi r squared, which is going to be 2,318 squared plus 2 pi rh, which is the radius, which is 2,318 times the height. Remember the height is there, which is 30. So from there, that was it, guys. We can simplify from your calculator, but everything now is on the ground. So we've got 2 pi times the radius squared, which is 2,318 squared, right? We can close the bracket, plus 2 pi r, so it's going to be 2 pi times r, which is 2,318 times 30. So that was it. From your calculator, we are going to obtain 470,693. So it's 470,693 square centimeters. This is area, surface area. It's measured in square units, so it's going to be square centimeters. Okay, so that was it on 3.5. Let's see the 3.6 now. 3.6, we're asked to calculate the area of a farm when the coordinates are surveyed 500 kilometers apart. Okay, so this is what we have, and these coordinates are actually 500 kilometers apart. So guys, we know that for us to have our formula, remember the mid-ordinate rule, that our area, we are going to have area as the sum of the first and the last ordinate over 2. So remember, we add the first and last over 2. Okay, so it's going to be 0.25 plus 0.3, everything over 2, plus the sum of the rest, which is the remaining ordinates. So you add these ordinates from this part up to this one. We have to add everything together. Okay, so if we add this, we can obtain something like 18,1. Then times the distance between the ordinates. As you can see, these ordinates, they are separated 500 kilometers apart. So you have to multiply by 500. Okay, so that was it from this one. So you can simplify further. So the area was going, if we simplify this, we're going to have something like 0.275 plus 18,1. Whatever that we get, we multiply to 500. So if we add these two multiplied to 500, we are going to obtain something like 9187,5. Remember, this was in kilometers. So meaning to say our area is going to be in square kilometers. Okay. So if it was centimeters, square centimeters. If it was millimeters, square millimeters. So you use the units the way that you are given from the information that you have. Okay, so that was our question 3. Let's move on to the 4th question of the paper, which is we are given the graphs. Y is equal to minus x squared. This one, which is the quadratic graph here. We've got the quadratic graph here, which is, and also the straight line. Okay, so that was the information. That's your graph here. Determine each of the following coordinates. Okay, 4.11 A and D. The axis intercepts of y is equal to 2x plus 12. Okay, y is equal to 2x plus 12. We need the coordinates of A and D. So we've got A and D. All right. That's our point A here, and that's our point D. So as we can see that x from the point D, okay, let's just even write it here. It's taken from the line. This is 4.1. Okay, so this is from 4.1. I think it's going to be 4.11. So from the line of y is equal to 2x plus 12, A here is actually the x-intercept. Okay, then y is the y-intercept. And we know that in the x-axis, y is equal to 0 as usual. Here, y is equal to 0. And in the y-axis, x is equal to 0. So that was the idea that we are going to use. So to find A, which is the x-intercept, the A that we see here is the x-intercept. So for you to have the value of A in the x-intercept, you know that y is equal to 0. Remember, guys, a point is made up of x and y. So we know that y is equal to 0. So if y is equal to 0 here, what is the value of x? That is the question. Okay, so transpose the 12 to the other side is going to be minus 12, which is equal to 2x divided by 2, divided by 2. So x was going to be negative 6. So that was the point A. Then we move on to the point D. Remember, this is A and D. So the D part is the y-intercept. So in the y-intercept, we said x is equal to 0. So we've got 0 here. So if x is equal to 0, it's just a substitution here. If x is equal to 0, therefore y is equal to what? That's 0 plus 12, which is 12. So y was going to be 12. So we've got the coordinates of A and also the coordinates of B. Okay, we move on to the other part, which was 4.12. B and C, that is the x-intercept. Take note, we are talking about the x-intercept, and we said for any x-intercept, y is equal to 0. So that was it from this one. So what can we do now to calculate these x-intercept, guys? What can we actually do? Okay, take note of the equation. This is 4.12. I'm going to have it here. 4.12. Remember, the equation was y is equal to minus x squared plus 8x plus 12. This was the equation that we are given here, minus 8x from this part. Okay, so if we are to cross-check here, we have got minus 8x plus 12 minus x squared plus 8x plus 12, which was something that was actually wrong. The actual equation is this one that was written on the graph. So this was actually an error which happened. This one, y is equal to minus x squared plus 4x plus 12. this was the one which was supposed to be the original equation. So this was actually an error, but under exam condition, because if you are to cross-check, this was actually 2 marks for you to solve this. It's 2 marks. And look at the equation, this one, which is the one that we are saying was wrong. So this paper was full of wrong things. Okay, so the actual was supposed to be y is equal to minus x squared plus 8x plus 4x here plus 12. The one that was written on the graph, that was the actual equation. I want you to see, because we are saying here, y is supposed to be equal to 0. I want you to see something. If y is equal to 0 here, that means we are going to have minus x squared plus 8x plus 12, which is equal to 0. And we can actually avoid the negative, which is x squared, divide by negative, which is equal to 0 here. We can't solve this. We do not have factors here. So, which means we're ending up using the quadratic formula to solve this, of which for 2 marks, that's impossible. Okay, but if you have to cross-check on this one, which is the one that I'm saying is the actual equation, it was going to be minus x squared plus 4x plus 12 is equal to 0. Okay, divide by negative is going to be x squared minus 4x minus 12 is equal to 0, like that. We have got the factors here, we can obtain them. We've got minus 12, which are the factors, which is minus 6 and 2. Remember, if we multiply minus 6 and 2, we get minus 12. If we add, we get negative 4. So these were the factors. So we're going to be x minus 6, x plus 2, which is equal to 0. So x was going to give us 6, or the other x was going to give us negative 2. So this was the actual equation, and that was an error. So now we can compare which one can be minus 2, because take note where there is b and c. This is where our b is, and this is where our c is. So b is a negative, as you can see. Then c is a positive, because this is where we have got our y-axis here. So b is a negative. Okay, so since b is a negative, that means b is going to be this one of 2. So the point b at the end was going to be negative 2, 0. And the point c was going to be the positive, which is 6, 0. Okay, so that is what we had from this one. So if we are to use the quadratic formula on this other one, if let's say you used that condition, that means we're going to solve, use the quadratic equation, then you can obtain your answers. But that was, guys, for 2 marks, which is impossible. So that was an actual error that we had. Okay, 4.13, the turning point. So we are now asked to calculate the point E, which is the turning point of, we are still having the wrong equation here, which is the wrong graph. So you can use from this one. If you had to work with this one, I don't know, then you can do that, but you're supposed to go back to the original equation. But let's say you use this. Remember, the turning point is always at x is equal to minus b over 2a. So I'm going to have it from both equations, because here we've got the one which is an error and the one which is the correct one. So we know that at the turning point, x is equal to minus b over 2a. So let's say you used this equation, the one that was written there. It was going to be 8 over minus 2a, which is minus 8 over 2. Our a is minus 1, so x was going to be 4. So when x is 4, you substitute into the equation, then y was going to give you something like 28. So you've got 4, 28. If you use that equation. If you used this equation, because there are 2 equations there for the graph, if you used this equation, it was going to be x is equal to minus b over 2a, which is minus your b this time is 4 over 2a, which is negative 1. So it's 2 times negative 1, which was going to be positive 2. So if x is 2, then you substitute here, which means your y was going to be, we are substituting on this equation now, our x, which is 2. So it was going to be negative 2 squared, like this, negative 2 squared plus 4 times 2 plus 12. All right, that's plus 12. Like this. Okay, so it was going to be 16. Okay, so it was going to be 16. So if x is 2, y was going to be 16. So the point was going to be 216. If you use the actual equation, but if you had to work with that equation, which you said is wrong, Therefore, you're going to obtain another part which is different from what we have on this one. Okay, then we've got 4.2 where actually we are asked to draw, given these functions, draw the graphs that we are given. Okay, so let me just remove this other part. Okay, so we are given two functions to work on, and we have to draw these functions on the same axis. There we actually need a graph. Okay, we've got f of y, f y, which is equal to x squared minus 3x minus 4, and the other one, which was gx, which is 2, gx, which is equal to x is equal to 2. So that one is just a normal straight line. Okay, so on the quadratic graph, that is where we are supposed to work something out to draw this graph. So what are we supposed to do to draw this graph? We actually need the y-intercept, the x-intercept. So the y-intercept, we know that in the y-intercept, x is equal to 0. So if x is equal to 0 here, y was going to be equal to 4. So the y-intercept, that's a 0 minus 4. Sorry, that's a minus 4 here. Okay. Then we need the x-intercepts. For the x-intercepts, we know that y is supposed to be equal to 0. So if y is equal to 0, here we're going to have x squared minus 3x minus 4 is equal to 0. And we are supposed to solve this by factorization. We've got two brackets focusing with minus 4. The factors of minus 4, if we add them, we can get minus 3. That's minus 4 and 1. So we are going to have x minus 4, x plus 1 is equal to 0. So x is equal to 4, or x is equal to -1. Okay, these are the x-intercept, the y-intercept. You can also calculate the turning point if you want, but this information was enough for you to have the graph. So I'm just going to sketch. The side is just the normal equation. So here are these points, they're actually enough for you to draw. So we actually need a graph paper. So I said the y-intercept is 0 minus 4. So let's see the y-intercept. I've got a graph here. So I'm just going to have this 0 minus 4. Which is somewhere down there, somewhere down there. Okay, so it depends with what you're going to have, but we can just have it somewhere here. 0 minus 4, that was somewhere here. Okay, then the x-intercepts, we've got 2, which is at 4 and -1. So we need 4 and -1. So this is -1 in x, and that's a 4 here. So you can actually have your sketch. As we can see, it was actually a positive. So that means our graph is going to maintain a cup shape like that. Okay, so we are going to have our sketch. Okay. All right, something like this. All right. So it has to be something that is nice, guys. You have to have yes because of what I'm using here. So it's going to be something else, but your graph was supposed to be at least smoother than the one that I'm drawing here. Smoother. All right, we have to go back to 4 here. So I don't know if we are going to reach there properly, but that was supposed to be the sketch. Actually, I think the scale that I used here is too much, but it's supposed to be something like that. That's something like this. Okay, so we just have to draw properly, guys, your graph here, but it's supposed to be something like this. So that's y is equal to x squared minus 3x minus 4. And the other one, it was x is equal to 2. X is equal to 2 is a straight line. Where x is equal to 2 here, just draw a straight line. So there we just needed a ruler for us to have this. We just need a ruler here. I think that was enough. Okay, so let's put it this way. Okay, so at x is equal to 2 here, this is where our x is equal to 2. You just have to draw a straight line. So that's a sketch, but guys, you're supposed to do something nicer than what I'm having here. Okay, then you write down your equation, x is equal to 2. Okay, then that's it. So from these graphs, the other question now was for you to provide the coordinates of the point of intersection between the graphs. So there was a point of intersection between the graph here where these two are intersecting. So the two graphs, do they intersect? Yes, they do intersect at a certain point here. for me, they are intersecting at this point, which is a 2 minus 6. So this was 4.22. So the point of intersection is here, where we have our x, which is 2. So our x at that point is 2. And y, according to my graph, it's minus 6. So you take according to the graph that you have. But for me, it was 2 minus 6. Okay, so that was it, guys, for this part. They just needed you to have something like this, then you can actually simplify. So that was question number 4. 0.22. Okay, so let's see the other part on the other one. Okay, 4.3, given the functions hx, which is cos x plus y, and draw the graphs on the same axis. Okay, on the same system of axis. So that one, we're supposed to draw these graphs. And as we know, if we are actually dealing with cos and sine, we can draw a table, is fine. Let's see what we can do on this one, on this graph. Maybe it can actually help us from 0 to 360. I don't know if it is going to actually give us what I need here. All right, sorry for that, guys. So let's just have our table here. Okay, so I've got h, which is cos x plus 1. Okay, I'm just going to have it here. I think it can work. Cos x plus 1. Okay, so this was our h. All right, h y, which is cos x plus 1. Okay, so you can actually have a table of values. So on the table of values, guys, don't have something which is much. You can just have your points, the values of x and y there. So I'm just going to have our x, y. That's 0 degrees, 90 degrees, 180 degrees plus 90, which is 270 plus 90, which is 360 degrees. Okay, so from your calculator, you can actually simplify this one. The first one is 0, so it's cos. So you can actually use your calculator. Cos 0 plus 1, you get a 2. So it's going to be 2. We move on to the other one, cos 90, just like that until the last one. So here we put a 90, cos 90 plus 1, which is a 1. We move on to 180, which was going to give a 0 and a 1 and a 2. So these points are enough. You can actually draw your graph. Okay, so we've got 0 versus 2. So let us mark our points. 0 versus 2. We can mark it here. That's 0 versus 2. 90 versus 1. So that's 90 versus 1 here. 180 versus 0. 270 versus 1. That's 270 versus 1. 360 versus 2. Okay, so these are the points. And we can join these points to have our graph, just something of this nature. All right, so that was the graph for cos. So this is the graph of y, which is equal to cos x plus 1. Okay, from 0 to 360. So it depends with the range or the interval that you have chosen to use. I don't know which one was best for you. Okay, then the other one was for sine x. Let's cross check. This is sine x. Okay, y is equal to sine x. So we can have our table again, just like what we did for cos. But this time we've got y, which is equal to sine x. So just like for cos, guys, we just have a table and make sure we've got the values of x and y. So the values are from 0 to 360 again, 90, 180, 270, 360 degrees. Okay, so these ones you can simplify. That's 0, 1, 0, negative 1, 0. So use your calculator, guys. Sine 360, sine 1. You just use your calculator direct. Now you can mark these points direct. Let's start with the first one, which is 0 versus 0. So we've got 0 versus 0 here. 90 versus 1. So 90 versus 1 is repeating. 180 versus 0 here. 270 versus minus 1. 360 versus 0 like this. So this is the graph that we're going to have at the end. It was going to be like this. Okay, it goes back to 180 there. It goes to negative 1, then it goes to 360 like that. Okay, so this is the graph of sine. So you can write the equation y is equal to sine x. Okay, so that was the consideration of the question 2. just to draw on the same axis. So we've got your two graphs, the one of cos x plus 1 and the one of sine x on the same axis, on the same graph. Okay, on 4.32, now we are asked to provide the coordinates of the point of intersection between the graphs drawn in question 5.31, not 5.31, 4.31, which is this one. So guys, okay, anyways, let's see. Where do we have the points of intersection? These two graphs, they are intersecting here on this one. It's an intersection where x is 90, y is 1. So that was 4.32. Okay, 4.32. So the first point on the intersection is 90 versus 1. So it's at 90 degrees versus 1. And let's see another one. If we've got also here at 180 versus 0 here. They are intersecting here. So that was 180 versus 0, 180 degrees versus 0. Okay, do we have anything? Any other? We do not have. So those were the 2 points that we had, which are the points of intersection from the 2 graphs that we had drawn. Okay, 5. Solve for all values of theta, the equation below, if tan theta is equal to -1 from 0 to 360. Okay, we are given that tan theta is equal to -1. Okay, from 0 to 360. The negative, guys, I told you this one is just for the quadrant where we are going to have our answer. From all students take calculus, we understand that tan, it's a positive here on all and here on tan. That is where it is a positive. But since our answer is a negative, we are going to have our answer here. Tan is a negative here. Tan is also a negative here. So these were the quadrants that we're going to use. So don't mind this negative. Just simplify your theta, because we know that theta is going to be equal to arctan 1, not with a negative. We just need actually to find like a reference angle that we can have, so we can avoid even writing it as theta. We can write it as alpha, then we calculate the actual theta from there. Okay, so that's arctan 1 from your calculator. Arctan 1, that is shift tan 1 here, which is 45 degrees. So we now know that there is an acute angle of 45 degrees in the quadrants that we talked about. But remember, we said our answer is going to be in the second and in the third. So in the second quadrant, we are going to have something like this. In the third quadrant, something like this. So this is where we have our 45 degrees. That's our 45 degrees here. Our 45 degrees here. But the theta now, the actual angle, remember, is always taken from the positive horizontal to where the reference angle is. So this one is going to be 180 degrees minus 45. 180 minus 45, which is something like 135 degrees. That's the theta now that we are talking about. So theta is equal to 135 degrees. Or another theta here from this part here that we have. Let me show you. From this part up to this part here, it is going to be 360 minus 45. As you can see, here it's going to be 360 degrees minus 45. 360 minus 45, which is 315 degrees. Okay, so these were the values of theta, 135 degrees, and the other one was going to give us 315 degrees. Okay, so that was it. Question 5, an artisan must determine the lengths between several points of a floor plan. The information available is limited as shown in this diagram. Okay, so that was the information that we're given. You're given an angle of 33 degrees, 15 minutes. So depending with your calculator, you can use it in degrees and minutes, or you can actually have it in another way, depending with your calculator, guys, depending with your calculator. Okay, but you can use degrees. Obviously, most of us, we use Casio, so we are going to have degrees and minutes. So the first part was calculate the length of AB. How can we calculate the length of AB, guys? AB is already given. This is A, this is B. The length of AB is already given as 96 meters. So you see this paper had a lot of errors. So 3 marks for calculating AB is nothing like that. Okay, anyways, that is what we had. 5.22, the length of BC. So BC here, this is our BC, this length. So according to this angle, we know this is our adjacent and this is the hypotenuse, the size that we are given. So which means we can actually apply our identities, our ratios 5.22. Okay, so this is 5.22. We know that adjacent and hypotenuse from SOHCAHTOA. So this is SOHCAHTOA. Adjacent hypotenuse are found on cos. So cos of theta is equal to adjacent over hypotenuse, which is cos of 33 degrees, 15 minutes is equal to the adjacent, which is 96, over the hypotenuse, which is the one that we are calculating, which is BC. So to calculate BC, we can actually cross multiply because that's a fraction here. So we're going to have BC cos, so that's BC cos 33 degrees, 15 minutes is equal to 96. So to find BC, divide by cos 33 degrees, 15 minutes, divide by cos 33 degrees, 15 minutes here. So this can actually cancel out. We remain with the BC that we need. Okay, so from your calculator, take note now on your calculator, it is going to be here. We have got degrees and minutes. So this is what you're going to do. It's 96 over, that's going to be cos 33. So we've got cos 33. This is degrees like that. Okay, 15 minutes. Press that one. So like that. So we can have our answer as 114.793. So it's going to be 114.793. Okay, so that's it. Okay, let me write it here. So you said we've got 114.793. The units is meters. So this is going to be meters. So that was your BC. Or if you wanted, you're going to change 15 degrees to 15 minutes to degrees so that we can actually work it in degrees. Remember, in a degree, we've got 60 minutes. What about 15 minutes? We divide. So it's going to be 15 over 60, which is something like 0.25 degrees. So we add now 33 plus 0.25. So this was going to be 33.25 degrees. If you wanted to use degrees only, but we could have just used like that. Your calculator, guys, is very, 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 very clever. It can calculate everything. Okay, 5.3, which is last part of the question paper. You're asked to calculate the length of a chord of a circle with a diameter of 42 millimeters. So let us name everything. The diameter is 42 millimeters and the height of the segment is 10 millimeters, which is X. We are asked to calculate the length, which is X. Remember your formula from the formula sheet. We are given that the diameter is equal to the height plus the length squared over 4 times the height. So this is the formula that we are given. So you can actually substitute. Since we want to calculate X, we can just substitute everything. The D is 42. So 42 is equal to H, which is 10. So it's going to be 10 plus X squared over 4H. 4H means 4 times 10, which is 40. So it's going to be 40 here. Okay, since we want to calculate X squared, X, we've got X squared, we can transpose first this 10 to the other side of the equation. So it's 40 minus 42 minus 10, which is going to be 32 is equal to X squared over 40. So before that, we can actually cross multiply to remove the fractions. So that means 1 times X squared, that is X squared is equal to 32 times 40, which is 1,880. To find X, we just have to introduce the square root, which is going to be square root of 1,280. That's 16 square root of 5 or 35.777 like that. So it's going to be 35.777. So that is our X. Then the units now, we are given the other dimensions in millimeters. Take note, this is millimeters. So we are going to have our answer also in millimeters. So it's going to be 35.77 like that, millimeters. So that was the length the one that we are asked to calculate. which is the length of the chord. So that was it, guys, for this question paper, for you to obtain a total of 100 if we had no mistakes. But because of those mistakes, it's from the department, so it's going to be 3 marks for any mistake that they do. But for this one, we can't say it's a mistake. We just have to determine that. We just have to put the answer, even though it's 3 marks. Just write 96. You got to 3 marks because that's their own mistake, guys. It's not your mistake. So it's actually 3 marks for us. Okay, so that's it, guys, for Mason African Motives, working on engineering here, this platform. Let us not forget to share our videos to your friends and colleagues so that they also can see what was supposed to be done. If there is a need for preparation, again, for this level, or you need to prepare for the next level, which is Mathematics N3 for next year. But that's it, guys, for Mason African Motives. Till we meet